So, in the previous class, we derived the relationship between S to Z, where we understood that how the Laplace is transformed to Z domain by making use of backward difference method, and this is the formula for backward difference method. So now wherever S appears in your equation, you are supposed to replace it with 1 minus z inverse divided by t. What is t in this case? It is nothing but a cutoff frequency or sampling rate. And it is also possible for me to go back to S domain from Z domain, that is Z is equal to 1 divided by 1 minus ST, which means that I have a digital filter H of Z. If I want to move back to Laplace, or in another way, I call it as moving from a digital domain to analog domain, then I will be using this formula. Wherever Z appears in my equation H of Z, I replace Z by 1 divided by 1 minus ST. So again the T remains same here, it is a sampling frequency or cutoff frequency, right? So this equation Z is equal to Z is equal to square root of 1 plus omega square t square divided by 1 plus omega square t square into e to the power of j tan inverse of omega square t square is nothing but the equivalent digital frequency. And we also understood how to map a pole 0 onto Z domain. And this is where we consider this, and before to that we are supposed to make a very important observation that whether this Z will going to fit within the unit circle or not. This Z equation is holds good if and only if all the frequencies of omega mapped within the unit circle. If it is not going to be mapped within the unit circle, then whatever we designed this equation for Z will be unstable. So in that case, we derived and we could able to cross verify our value that we took this equation Z equal to this particular equation here. And if we observe this, the same equation, if we observe this, we consider this to be as x and another to be as y. And if I square x and if I square y, and when I add it both of them, I'm going to get x again. So this was I'm getting. So this is just an observation from the equation. A slight modification, that is 1 divided by 1 plus omega square plus j t square plus j times omega t divided by omega square plus t square. When I make the square of this, when I take the square of this and this, it is going to be giving me the back the x itself, which is nothing but a circle equation with a radius of 0.5. Therefore, I conclude that whatever the derivation that we have made for Z is a stable system, because if I map the unit all the frequencies of omega, definitely it will fall under the unit circle. So that's a conclusion that we drawn from a previous session. Now in this session we will move on to solving some examples. So one of the main difference that what we observe from from impulse invariance to this is, in impulse invariance method, if you remember, the frequency mapping was from omega by t to minus omega by t only. So this was the maximum frequency that we have chosen. This to this minus omega by t to plus omega by t only, which means that all the frequencies, when I say that all the frequencies, it must be ranging from minus infinity to plus infinity. This was not possible in impulse invariance method. So, which means that the higher frequency component were not able to map it on Z plane. So, because I was not mapping my frequency from minus infinity to plus infinity, I was mapping the frequency from somewhere else in the middle with some range of frequencies, only some few range of frequencies I can able to map it on Z domain. So, which means that it fails to map the high frequency component or high pass filter. It was good to design only the low pass filter. It is not that suitable to use it for, which means the impulse invariance method is not that suitable for designing the high pass filter. Now, that particular disadvantage could be able to overcome in uh, in here, that is in case of approximation of derivatives. But even this is also having some disadvantage. What is the disadvantage? The analog frequencies is mapped onto the circle of less than unity. As I told you, I expecting the frequency to be mapped within the unit circle, but we got to know that I can map all the frequencies only within the this range, which is less than unity. So this was one of again one of the disadvantage. Sometimes what happens is poles of the left hand side of S plane get mapped onto the outside this circle many a times. So when it happens, which means that the system is going to be an unstable system. That is one of the disadvantage in this case. With that, we'll move to start solving the examples. The problem statement goes like this: analog band pass filter of second order system with a system transfer function h of s is equal to 1 divided by s plus 0.15 the whole square plus 8. So convert this to digital domain, convert h of s to digital domain using backward difference method. And he has given you the sampling frequency fs, that is equal to 100 hertz, which means that t is equal to 1 by fs, that is equal to 1 by 100. Now what we are supposed to do? I need to transfer this h of s system, which is analog system, to a digital system. To a digital system, it is h of z, by using backward difference method. By using backward difference method. How do you solve these examples? By using backward difference method. By using backward difference method, I have already, so for a given h of s, to move or to transfer this to h of z by using this function, I need to replace the s value with what? with this value. That's what we have derived. That is this equation. So replace the S by 1 minus Z inverse divided by T. So you just replace your, wherever you find the S, 1 minus Z inverse divided by T. So this is supposed to be chosen. And he has given you the sampling frequency, he has given, that is 100 hertz or 100 cycles per second. Now I need to take this to be as a 100, 1 by t equal to 100 here, right? 1 by t is equal to 100. So directly I can put it here. So given that h of s equal to, it is a given transfer function in analog form, that is 1 plus 1 divided by s plus 0.15 s square plus 8. To move this by using the backward difference method, I should replace s by 1 minus z inverse by t. So therefore, this is going to be h of z is equal to h of s, where s is equal to 1 by z inverse by t. So this is equal to 1 divided by s is to be s supposed to be replaced by 1 minus z inverse divided by t plus 0.15 whole square. This entire thing getting squared plus 8 as it is. Simplify this and try to perform the operations. Consider 1 by t equal to 100 directly, because he has given in terms of 100 hertz. Okay, so directly I take this 1 by t equal to 100. So I just consider, or keeping this, you keep t till end, and at the end you can replace t by 1 by f, or replace t by 1 by 100. That's left to you. However you feel comfortable, you solve accordingly, right? So you just take this. So this will going to be 1 minus z inverse whole square a square plus b square, that is 0.15 the whole square, plus 2 times 1 minus z inverse divided by t into 0.15. So this is a plus b whole square formula, plus 8. So I request each one of you to simplify this. Then when you simplify this, directly I write the answers to just to save our time. So we're going to get in the numerator 10 to the power of 4, and this is going to be a quadratic type of equation, polynomial 2 z to the power of minus 2 2.003 z inverse plus 1.0038. So you need to substitute the value of t, you will going to get this answer, no doubt. So this is what? This is my digital domain transfer function. So this is transfer function in digital domain. So that's it. Now along with this, he has elaborated the question. Let me go back to question and read it once again what the question talk about. So the second part of this question is to plot the poles in both Z domain and S domain. What is required to plot the poles? You will be having a characteristic equation, right? You will be having a second order characteristic equation or third order characteristic equation. Totally you will be having some polynomial. Look at this equation, h of s equal to, h of s is equal to numerator, denominator, numerator and denominator, and whereas denominator is a quadratic equation. If you carefully observe, it is nothing but a quadratic equation. You need to solve this quadratic equation. When you solve this, you will going to get the roots of the characteristic equation. So what is the meaning of this roots? Roots are nothing but what? Poles, right? Poles. If it is if it is in the numerator characteristics, then I would have called this as a zeros. Since I am solving the quadratic equation of the denominator, then I call this as a poles. What is this zero? Zero is nothing but a frequency that I want to suppress. What do you mean by pole? A frequency that I need. So I am placing one pole in that particular location, in the S plane or Z plane. I am trying to fix one pole, which means I need that frequency component. If some of the frequency component I don't want, then I will be placing a zeros. That's what the meaning of poles and zeros. Now what you need to do? Solve this characteristic equation. Very simple. You will going to get a characteristic equation with second order. Solve for the quadratic equation. Find out the roots. You will going to get the two roots, which is nothing but a poles, and definitely these poles will be a complex conjugate, no doubt at all. So let us solve this, and we'll see whether those poles will be a complex conjugate or not. So denominator, I consider denominator function, denominator from h of s. I'm sorry, h of s. So where the denominator functions is s plus 0.15 whole square plus 8. So kindly solve this for the quadratic equation. Solve it quickly and let me know the this one. So if I expand this with respect to a plus b whole square, and if I simplify, so this will be s square plus 0.3 times s plus 8.0225. Okay. Now I think it is better to use your formula, that is to calculate x equal to minus b plus or minus square root of b square minus 4ac formula divided by 2a. Use this formula and calculate the value of s. Find out the roots of the characteristic equation. I'll just give you some time. Let me know the answer. So here I took the denominator of z domain, which is the characteristic equation from here, h of z equal to 10 to the power of minus 4 denominator term. So in the denominator term, once again I can able to see the quadratic equation form. I am considering that to find out my poles in z domain. So I replace z inverse by x for my simplification purpose, so that this becomes x square minus 2.00. It is 2.00. How much? 3. Sorry, 3 is missing here. 2.003, 2.003 z inverse plus 1.0038. So later on, once I could able to find the x, I just make this 1 by z to get this actual value of sorry, not. So I can get the z value is required, so that is 1 by x. Okay. This is how I try to ensure the z plane. Okay, so you need to calculate the z plane, check out the z plane, and your value, the roots of the characteristic equation should lie between minus 1 to 1. Minus 1 to 1. Here in this we solved the equation to find out the characteristic equation of S domain. So here this was a quadratic equation. Once again, after solving this, we got the the roots as 0.15 plus or minus j 2.82, which means that two roots I'm going to get which are complex conjugate. S0 and S1 are complex conjugate. So that's what I mapped onto the S plane. Now it is time to map this S plane to Z plane. So here once again I have a h of z equation from the denominator. I took this. Now we are supposed to solve this and get me the value of x. Get me the value of x. So when we solve this, we're going to get the equation or roots of the characteristic equation as 1.0015 plus j times, I mean plus or minus j times 0.0282. This most of you have got it. So what is required? I need z. I need z means it is 1 by x. So when you perform this 1 by x, that's what Rohan already got the answer. This is going to be 1 divided by 1.0015 plus j times plus or minus j times 0.00282, and thus you will going to get 0.997 plus or minus j 0.2821, and if you map it onto the z plane, so well within the unit circle, right? So here I'm if I closely write this, so this is 0.99. So somewhere else here I'm going to get well within the below 1 or nearing to 1 approximately. So here I can able to find my poles in the z plane. So this is z0, this is z1, which is complex conjugate of z0. That's it, right? So this is called as mapping of poles from S to Z domain. That's it, guys. Okay, is there any doubts? So this is the second example where here he's talking about sixth order analog Butterworth filter. I want to make one point very clear. Listen carefully. SK, I think if you remember my good old derivation on Butterworth filter, there we derived the value of n, which means that how to find out the order of the filter by using Butterworth approximation and Chebyshev approximation. But we haven't derived a separate derivation for to find out the poles. To find out the poles, it was only one equation, that is omega c e to the power of j pi. Okay, this is n plus 2k divided by 2 to the power of n, 2n. So if you remember properly, this was our the n plus 1. I'm sorry, I just forget to write this. I rewrite this. This was the formula that we derived in Butterworth equation, and this remains same even for Chebyshev. N plus 1 plus 2k divided by 2n. Okay, so this was the equation to find out the poles. Okay, where omega c is the cutoff frequency. Now here, even if you observe here, it is the sixth order, which means that n equal to 6. If you put this 2 into 6, we're going to get the denominator 12 here. And n plus 1, 6 plus 1, 7, you will going to get plus 2k. So this is the same equation that they have given here. Okay, this is the formula to find the poles when order of the filter is given, and this is pole number 1. What is k? K is nothing but for ranging from 0 to n or less than n, that is we are considering from 0. which means that if there are 4 poles, then you need to find out S0, S1, S2, S3. So that is what we call it about SK is all about. Now this is cutoff frequency. From this I can ensure that the cutoff frequency is 5 radians per second. One point. And second point is I need to determine the set of poles. How do you solve this? By put k equal to 0, k equal to 1 till what value? Till it reaches 5, because the k value will be moving from 0 to n minus 1. So just go on substituting the value of k from 0 to 5. So you will going to find the poles s value, etc. That S value indicates what? The poles in the S plane. The poles in the S plane. Okay. So if I substitute the value of k equal to 0, 1, 2, 3, 4 up to 5. So totally 6 poles. And if you find only 3 poles, that is sufficient, because the rest of the 3 poles will be complex conjugate. Right? Uh, and here this S0 to S5, these are the poles that belongs to what? S plane. Now what they have asked? They have asked us to find out the poles in the digital domain by using backward difference method. So this is where we should understand, like we know that there is a relationship between S and Z, that is 1 divided by 1 minus Z inverse divided by T. So this is the S is equal to transformation relation, right? 1 minus Z inverse divided by T. So what is Z in terms of S? Z is nothing but 1 by 1 minus S into T. And they asked us to consider this t is equal to 0.01 second. In the question they have given. So this t is given. T is 0.0. You consider this to be 0.1. 0.01. Okay. I'm sorry. 0.01 seconds. So how do you calculate? So this is for single pole. What is needed? I need a k number of poles in Z domain, that is 1 minus sk into t. Right? What is sk? Sk is given. What is sk? Sk is given in the problem statement itself. It is 5 into e to the power of j pi into 7 plus 2k divided by 12. 7 plus 2k divided by 12. This is given. I just substitute here. S is equal to, Z is equal to 1 divided by 1 minus 5 into e to the power of j pi divided by, e to the power of j pi into 7 plus 2k divided by 12 into 0.01. Fine. So this is the value of t I am trying to put it here. So what about zk? Zk is nothing but 5 into, I make a 5 into 0.01. I perform this 5 into 0.01. So this will, somewhere else I am going to get 5 ones of 5. So 0.05. So I'll rewrite this as 0.05 into e to the power of j pi 7 plus 2k divided by 12. Okay. Now I consider this e to the power of j theta formula. So this will help me. Either you can put k equal to 0 directly here like this and calculate e to the power of j value. It is the direct, since it is consisting of imaginary term, you must use this formula, no other way. Idu j irlilla antandre you would have calculated very easily e to the power of something directly in the calculator you would have gone, but e to the power of j theta ide andaga you have to apply this formula cos theta plus j sin theta. Okay, so convert this. So zk is equal to 1 divided by 1 minus 0.05 cos of cos of pi 7 plus 2k divided by 12. Okay, so this is one term. This is one term, and uh, okay, I'll just write minus. Let me take a eraser here. So let me, okay, so that you will not get confused. Minus into minus, it is plus. Sorry, this is minus into plus, it will be. So therefore, here also I'll going to get minus. Okay, let me multiply 0.05 to sine also. 0.05 sine of pi 7 plus 2k divided by 12. Okay, now put k equal to 0. You need to make some table here. Calculate the value. Now calculate the values. Z is equal to k equal to 0 and z k equal to, okay, k equal to 0, k equal to 1, k equal to 2, k equal to 3, 4, 5. For all these value, please calculate the k. So it will be 1 divided by something. So you need to take 1 divided by something to uh, the real numerator value. 1 divided by, once again you need to divide that value. We will going to get the final answer. Will you solve it? So that you can able to find out the 6 poles in the Z domain. All the values should lie within the unit circle. System is stable. Okay. I'll just, for your hint, I'll just write one of the value 0.850 plus j times 0.0470. Okay. And another value 0.9647 plus j times 0.0330, and another one is 0.9538 plus j times 0.0117. So definitely this will be complex conjugate of second pole, and fourth one will be complex conjugate of first pole. So, and this will be complex conjugate of zeroth pole. Okay, that's it. So let me stop here for the day. On Monday, I will take up one more topic, bilinear transformation. Bilinear transformation, only single problem I am going to cover. And see, the point is very simple. You got to know how to solve the examples. Even in bilinear transformation, we try to find out the relationship between S and Z. As we found in this case by a backward difference method, where S equal to 1 minus Z inverse divided by T. ಈ ತರ ಏನು ರಿಲೇಶನ್ಶಿಪ್ ಇದೆಯಲ್ಲ, ಸೊ ಸಿಮಿಲರ್ಲಿ ವಿ ಟ್ರೈ ಟು ಫೈಂಡ್ ಔಟ್ ದ ರಿಲೇಶನ್ಶಿಪ್ ಬಿಟ್ವೀನ್ ಎಸ್ ಅಂಡ್ ಝೆಡ್ ಇನ್ ಕೇಸ್ ಆಫ್ bilinear transformation. Again same thing, replace S by some relationship in case of bilinear transformation and solve for the h of S to h of Z. That's it. The problems will remain same, and there also you are supposed to map the S plane to Z plane, all pole mapping of pole from S plane to Z plane, and finding out the poles. Everything remains same. So ಒಂದು hint ನೀವು ಅರ್ಥ ಮಾಡ್ಕೊಂಡ್ರೆ you can able to solve all the examples on the similar line. I hope you got this particular these two in this class. So if you have any doubt, please let me know. I'll come back to chat room.